Okay guys, so we have created a Maven project through Eclipse. Before that we had created a Maven project through Maven CLI. Now let's understand the directory structure one more time, right? We had discussed it though, but let's understand it once again and then we will start implementing our application. So this is our project. Okay, Ramesh, can you please go on mute please? Yeah, so this is our project. Inside this we have src main java. This is our source directory in the sense our application source code is going to be present inside this directory. That is what Maven understands. Maven understands this as a default source directory, and this src test java is our directory where we are going to write our unit test case code. So Maven understands this src main java as default source directory and this src test java as default unit test case directory, wherein it will find the unit test case classes. Okay, that is the understanding for Maven. Then here in this Maven dependencies you will see different dependency jar files connected to your project. So as of now we have a JUnit here, okay, but we are not going to use JUnit, which is again a unit testing tool for Java environment, but we are going to use TestNG, which is a unit testing tool for Java environment, which is quite latest as compared to JUnit. Okay, so we are going to use TestNG. Please remember. Then we have a pom.xml. We had understood this pom.xml in our last session. Now this directory structure has been created by the plugin maven-archetype-quickstart. Okay, and that plugin creates this template source file. If you see here, this is just a template source which has been created for us, and similarly in src test java you will see a template unit test file created for us. So we are going to delete these two files and we are going to create our own files now. So let's start with that. So I am going to first delete this app.java from src main java and this apptest.java from our src test java. Now here in src main java we have got the package directories created already. The package name is DevOps batch 1, which is a group ID of our project, dot calculator API, which is artifact ID. So group ID dot artifact ID is the name of our package. Okay, so I'm going to right click on this, a package directory, new, and let's create our class. Let's give the name as calculator API, or I'll say calculator. Calculator is the name of our class. Now we don't want a main method in this because we are creating a library class. Library class in the sense we are going to now create different methods here which some other application is going to consume as libraries. Okay, so there are going to be addition, subtraction, multiplication and division, few methods we are going to implement here, which other application going to call these methods in its implementation. So this is our library application wherein we have different reusable libraries written and some other applications are going to consume this library. Okay, so we are going to see both how to create a library class and how to consume the created library in a Java project. So both of the aspects we are going to learn. So calculator, and let's click on finish. So we have got this class. Now let's start implementing our very first method. I'm going to keep this application very simple because our main focus is about understanding Maven and about understanding the different life cycle phases of the application, and we are not our focus is not on understanding the Java concepts. Our focus is on understanding the Java application build concepts. So public int addition. So this is the first method we have. Now this method, let's have this method, and let's have, because I'm putting you on mute. So this method will have two parameters, int num1 comma int num2. Very simple. Okay, so this, whoever would call this method will send in the two numbers into it, and the job of this method is to add the two numbers and return the result back to the caller. Very simple. So as a developer, I am creating this class and I am implementing this one functionality. Okay, so when a developer implements a functionality, along with the functionality he also implements unit test cases. Please remember this. Okay, so in addition, num1 num2, and developer is currently developing this method. Now int result, so there is another method, another variable. This variable will hold the addition of two numbers, and it will simply return the result back to the caller. As simple as that. Okay, this is the implementation of this functionality. So developer will also write comments that addition function will take two numbers and add them, return the result back to the caller. Okay, this is the comment of a developer. Now developer has completed this functionality. Now what he needs to do? Then he needs to write the unit test cases. Unit test cases means at his end, before he creates a build and gives it to the QA, he needs to test if this functionality is working fine or not. So he will create unit test cases for this in this src test Java. So this src test Java is our folder where we would be having our unit test cases written. So let's create a class in this folder now. This folder will also have the same package created. Here also we have DevOps batch 1 group ID dot calculator API artifact ID package created. Here also we have the same package. So let's right click new and say class. Now here I will create a class called test addition functionality. Now this class is going to hold different test cases. So this class is going to, or this class has, I would say, different unit tests for addition functionality. Simple. Okay, so say developer wants to test this addition function with different kinds of inputs, say positive, two positive numbers, one positive, one negative number, then 0, then 1 0 1 non-zero. So different inputs he wants to test this addition function whether it works fine or not. And once it, once he checks this addition functionality, and once he is confident that this addition functionality is working fine, then he will create a build and will give it to the tester for further testing. Okay, this is what happens. So public void test addition with 2 positive numbers. So this is the first test case. So for every test case, we will have a function. Then test addition with 1 positive, 1 negative. Let's say the second test case. 1 positive, 1 negative. This is second. Then the third test case, let's say, would be test addition with 0, I would say 2 0 numbers. Then next test case would be 2 negative numbers. Test addition with 2 negative numbers. Another would be 0 and non-zero. With 0 and non-zero numbers. Okay. Now he wants to basically test this particular functionality with this 1, 2, 3, 4 and 5 test cases. Okay. Now for these test cases, to run these test cases and to generate a report, we need a tool, a unit testing tool called TestNG. Okay. So what TestNG is going to do is, TestNG is going to run these tests one by one, okay, and going to generate a pass-fail report. And once all the tests are passed, developer will create a build and will give it to QA. Okay. Now let's add TestNG now to our project. So how to add TestNG? So basically there are 2 ways to add TestNG. We already have installed TestNG in our Eclipse. Everyone, you guys have already installed it. So TestNG is available in our Eclipse. Here you can see, here there is a TestNG. So TestNG is installed, but we need to add it to our project. So there are 2 ways. The first way is you can simply right click on your project and you can go to this build path and say add library here. Once you say add library, you will see TestNG here. You have to simply click on this next and click on finish. Okay, so TestNG is added to our project. But we do not want to add TestNG like this, because we are going to run our build. That is, we are going to compile, we are going to execute our unit tests, we are going to package our build, not from within the Eclipse. We need to do it, rather we are going to do it outside of the Eclipse, from command line initially and then from our Jenkins pipelines. Okay, so TestNG we are not going to add in this way. So let me delete this. We want TestNG to be added as one of the library. I would just remove this. I'll just go to the properties and not from here. I'll just go here, right click, build path, and configure build path. I will go inside the libraries. Here is the TestNG. I'll just click here and I'll remove it from here. I don't want to be TestNG to be added in this way. I want TestNG to be added as a dependency. Okay, so let's go to the POM XML. So in this POM XML, where we have the entire details about the project, so we have got one dependency tag here. You can see dependencies open and this is dependencies closed, and this dependencies tag contains the dependency of a project. Currently we have a JUnit mentioned as a dependency. We do not want JUnit, we want TestNG. So I am removing this. Okay. Now let's get the dependency tag for TestNG. So how to get it? Let's go to our mvnrepository.com, from where we can get the details of all the libraries, Java libraries. So here I'll go and I'll say TestNG. So TestNG is also one of the Maven project, okay, which has been implemented, compiled, unit tested, packaged and deployed or released over this platform. So TestNG. So there are various, you can see, versions have been released so far of TestNG. So let's click on this latest release, and here we have got the dependency tag. So I'm just simply copying it and putting it inside the dependencies tag of our project. So Control V. So see, this is the dependency. Right. So I have added TestNG as a dependency for our project. Now let's understand what happens once you add a dependency in your project. So now this is the group ID of the TestNG project, meaning the group ID, as we already know that, which indicates the developer of the project. This is the name of the project. This is the version and scope. We will now talk about this. What is this scope? Let's see. Now as soon as you add the dependency, what happens is, let's remove this scope for now. Then I will add it back and will explain you what difference this scope makes. So I am just removing this. Removed, and I will Control S. I am doing Control S. As soon as I do Control S now, what happens? Maven checks if the dependency is present in the local repository of Maven. Now what do I mean by local repository? Let me show you. So you have to go to your current user directory. So in my case it is C users. So my current logged in user is Pranod D. So this is the user. I'm going inside this .m2 folder. This is our Maven's folder. Inside this we have this repository folder. This is a local repository where all the dependencies get downloaded. All the dependencies, all the required plugins of Maven get downloaded here. So as soon as any dependency is added to the project, what happens first? Maven checks if the dependency is already available in the local repository or not. So how does it check? Let's see. This is our local repository. Now what Maven does is, it first reads the group ID of the dependency, which is org.testng. So it will go here in this local repository. It will look for the org folder first, because our group ID has org. Then it will check for TestNG folder inside that org. So TestNG, this is how org.testng folder structure gets created for a group ID. Inside that, it will look for a folder with the artifact IDs. So TestNG is the artifact ID. You can see TestNG. Here it will check for a TestNG folder. Inside that, a folder with this version as name. So 7.8.0. So 7.8.0 folder it will check, and inside that it will check the jar file. This is the jar file, a library of TestNG. So Maven always checks if a dependency is available in your local repository or not. If it is not there, please understand, if it is not there, if it is there, then TestNG will simply add that dependency to your project. So let's see if our dependency is added or not. So how to check that? inside the project structure, you will see your Maven dependencies. Inside the Maven dependencies, you will see there is a testng jar and its dependencies added. So this jar and this jcommander. So this jcommander is the dependency for testng. It's not our dependency. Our project dependency is testng. But Maven takes care of downloading our project's direct dependency and all of its dependencies, which are indirect dependencies for our project. So Maven takes care of downloading all the recursive dependencies and added them to our project. So this is where we can see the dependency have been added or not. Now what I'll do is I'll delete this dependency. I'll simply go in this repository and I'll simply delete this org folder. Okay, currently it is not allowing me to delete because it's being used here. So I'll just simply close this and I'll say try again. Okay, so that folder has been deleted. Now let's start the project again. And this is my workspace. So I'm launching Eclipse, and now I want to show you like how this Maven downloads the dependency if it doesn't find it there. So now we already have added our project, right? Here you can see it is building the project. On the right hand side it says that it is building the project, meaning it is currently downloading the dependencies. Okay, I will just go here and let's see here that org folder is back again here, which I had deleted. Let's go inside this org. Inside the org, because that is how the group ID of the testng is, org.testng. So inside the org folder there is a testng folder. Inside that you will see a folder with artifact ID, testng artifact ID. Inside that a version folder 7.8.0, 7.8.0, and inside that the jar file has been downloaded. So Maven always checks first the local repository if a local repository contains the dependency or not. If dependency is there, Maven simply adds that dependency to your project. Point number one. If it doesn't get that dependency there, it downloads the dependency. That is point number one. And second, it adds that dependency to your project also. Okay, so here it has added the dependency to your project. Now let's understand what is the scope. Okay, what is the scope? Now this is going to be very interesting. The scope parameter here. So scope is basically it tells Maven, just a minute, I'll just mention this scope and I will say test. Now let's understand what is this scope. Now scope means it tells Maven when to download this dependency and add it to your project. Meaning there are different life cycles we talked about that day, right? If you guys remember, in the last session we had talked about different life cycle phases of a particular project build. Okay, so the first is it cleans the output directory. Okay, next it downloads all the dependencies and then it compiles the application source code. Then it triggers the unit test. This is the test phase. What is test phase in a project's build life cycle? Where Maven compiles the unit test case code and it triggers the test cases using Surefire plugin. Okay, this is the test phase. Compile phase. It compiles the application source code. Then package phase. It builds the jar file of the generated class files. Then install phase, where it installs the created jar file into the local repository, which we will talk about. Don't worry about it right now. And deploy phase, wherein it deploys the generated jar file to a remote repository. So there are different phases, right, which we talked about. Now this scope mentions to Maven that in which phase of a build life cycle, compile, then deploy, test, which phase it should download the dependency and add it to the project. Now let me show you one thing. Let's right click on this project. I'll go to this Maven folder, Maven menu, and I'll say update project. And I'll say force update. So I'm just updating my project with the recent changes into the form XML. Now I'm updating the jar, project. So let me delete the folder again, this org folder. Okay, let me close the Eclipse. Let me delete. I have deleted. Let me start Eclipse. And let's start our Eclipse workspace. Now please concentrate what I am saying now. Okay, let it start, and then I'll show you the difference that scope parameter makes. Okay, so our workspace is getting started. Once workspace is started, now this is our workspace started. Now let's see the Maven dependencies folder. Okay, this is fine. Now let's check. Just a moment. I think it has not been updated properly or what. Just a second. This scope basically scope, and I will say test. Okay, I have just modified it again, and I am updating the project. Okay, now let me start the unit test cases. Okay, let me just delete this org one more time. It is not allowing me to delete because of this again. Okay, so I am deleting it again. Let me start the project. Actually, that scope parameter defines when to download the dependency and attach it to your project, at which phase basically. It will not download the dependencies. Let's say if there is any test dependency means the scope is called test. Okay, so this is called test dependency, means this jar file your project needs only when you would be running the unit test cases, because this is a TestNG framework, right? TestNG framework jar file. So this our project needs only when we will be executing unit test cases, not for any other thing. Like our application source code doesn't depend upon this jar file. What this jar file we need is need this for running the unit test cases. So this test scope defines when Maven should attach this jar file to your project, at which phase of the life cycle, whether at the time of compilation, at the time of unit testing, at the time of packaging, at the time of execution, at which phase Maven should attach this jar file to your project is what this scope defines. Now let's see Maven dependencies. Let me refresh this. Let me refresh this and let me just right click Maven and I would say update project, force update. Okay. It is updating the project. Okay, let me refresh, and now here we have the test.ng jar file downloaded, but it's not connected to our project yet. When it would be connected, when I will run the test build lifecycle, I'll show you. See, right click, run as Maven test. This is the test phase. See here, it is downloading. Surefire and rest of the plugins, and then it is connecting our jar file to the build path of our project, and it is compiling our source code. Okay, let me now do one thing. Here this test.ng will not be connected to our project in other phases of the application. Let's say if I compile, simply compile, wherein I don't need that. So what this compile phase does, which we had already talked about in our last session, that this compile phase compiles the source code of our application. Okay, so for this Maven doesn't need, or our project doesn't need that test.ng jar file. Please understand that test.ng jar file is required only and only at the time of running unit test cases on our project. So when you are executing this compile phase, Maven will not connect that jar file to our project. I will just run this. See, it is not downloading anything, it is not even connecting any jar to our project, it is simply compiling our source. I'll create one more project to demonstrate this. Okay, let me create one more just sample project which we would be deleting afterwards. Okay, so Maven project, next, and here we have to say Maven dash archetype dash quick start. This is our plugin. I'll say next, and this is just a sample project. Okay, we will delete this afterwards. Sample and finish. Okay, let's go to that project. So this is our sample project. Inside this, though you will see the JUnit jar files, but they are not connected to the project. Okay, they are not connected to the project. Let me replace this with our test.ng. This is our test.ng. Control this. Now you can see that the jar files are not yet connected. Do you see this icon? Okay, it's not yet connected. Those jar files actually get connected to the project when you will run the test goal. That is when you will trigger your unit test cases. Okay, otherwise the jar files don't get connected to the project in the build path of the project. That is this scope is all about. It tells Maven when to connect the jar files to the project in the build path of or the class path of your project. That is what the scope parameter defines. Okay, now let's move on to the next thing. So I'll be now deleting this particular project which we don't need. Delete. So we are going to work on this calculator API project. Okay, so in this project so far we have implemented one functionality. We have added a test dependency, that is our test-ng. We have defined scope as test because we want this jar file to be connected to our project only at the time of execution of the unit tests. We don't need this for any of the other phases of our project. Simple as that. Okay, otherwise what happens is, like if you don't define this scope, if you don't define this scope, then the jar file remains connected to your project all the time. Let's assume that you have a project which has got 100 test dependencies. For an example, let's take an example. It has got 100 test dependencies, meaning you need those jar files or those libraries connected to your project only at the time of running the unit tests, not otherwise. Okay, but if you don't define the scope then what will happen? Those libraries will stay connected in the build path of your project all the time, and then your compilation or execution might take time because the Java compiler need to find the classes in all of those connected dependencies, which might take some time. Okay, so please remember, if you know that few of the dependencies you need only at the time of running the unit test, always define the scope so that those dependencies or jar files will stay connected in the build path or class path of your project only at the time of running the unit test. They will not be connected when you are compiling or doing other stuff with your application, and then that will definitely increase the speed of the compilation. Okay, so please remember this. Now let's talk about our unit test cases now. So we are going to write few unit test cases. Now the first is we are going to have one prerequisite. So what is the prerequisite for this class? A test class. This is a test class in which we are going to write all our test cases. So this test class, what it is going to do is, these methods, test methods, they are going to call our addition function which we have just implemented. They are going to call it, they are going to send it different types of arguments, and we are going to test it. But to test this addition functionality, what we need is, we need an object of this class, right? Without an object of a class, you cannot call any of the method inside it. So what is our prerequisite? Prerequisite for all these test cases, we need an object of a class. So the prerequisite we are going to handle in this. Then we are going to handle each test case in these individual methods, and then there would be a post requisite wherein we would be setting set obj to null. So we are going to, once all the test cases are executed and TestNG will stop the execution of this class, we want the object of that class to be garbage collected. We don't need that object anymore once all the test cases are executed, right? So that is post requisite. Post requisite is what we want to execute once all the test cases are completed its execution. Prerequisite is what we want to execute before any test case starts its execution. So what we want first, an object to be created. What we want at the end, that object to be garbage collected. Okay, so what we will do now here is calculator calc. So we are defining one variable of type calculator. Inside this method we will create the object of that calculator class and will keep it in our calc variable. Okay, so calc. Now why I have defined this calc at this class level? Because I want this calc to be accessible in all these methods here. If I define it here, no, the problem would be, if I define it here and not here, then the problem would be this calc variable would be defined inside this method and it would be only available inside this. I need this calc to call my addition function, right, in this test case method. So I want this to be available for all of the methods, right? That's why I am defining this calc variable at the class level here so that it would be available to all of the methods from that class, right? So I am defining it here and I am just assigning this variable with the object of our calculator class so that I can call my addition function now with different types of numbers and get it tested. So what is our first test case? The first test case, I want to test my addition function with two positive numbers. So what I'll do is calc dot addition. I'll call that addition method with any two positive numbers. So let's say 30, 50. Okay, 30 and 50. So my addition would be called with two positive numbers. It will do its job. It will return me the result back. And then we will have the assertion. What is assertion? That I have called here addition with 30 and 50. I am getting its result back and I want to check now whether this result is correct or not. Whether that result is as expected or not. That is called assertion, where we compare actual result with expected. That point is called assertion. So there is a class called assert in TestNG, assert equals. So I want to check the equality between this, whatever I have got here in this res, and what the res should have. If I am sending in the addition 30 and 50, then 30 plus 50 should be 80, right? So I want this res to be 80. Okay, so this assert, what it will do? This assert's job is to check if this res is equal to 80. If it is equal, then this assert statement will mark this test case as passed in the report of TestNG, else it will mark it as fail. Okay, and if the assertion is failed, that is somehow this addition has returned me wrong result, then I want this test case to be marked as failed with a particular message in the report. So that message I will write as a third argument to this assert equals. So basically the job is to check if this is equal to this or not. If yes, then mark the test case as passed. If not, then print this message in the report by marking this test case as failed. So I'll just put a message here: addition is not working with two positive numbers. So I'll just put some meaningful message here which would be printed in our report, so that a developer, once he will execute the tests, he will check the report, he should be able to understand what is not working. So if he sees this message in the report, he will understand that addition is not working with two positive numbers. So some meaningful message I can post in my report. Similarly, in this test case, I want to test my addition with one positive and one negative. So I would again say int res calc dot, I will now call the addition. So do you see here, I need this calc variable in all of these test case methods to call my addition method and get it tested. That's why I have defined this calc at the class level. That was the reason. Now let me send one positive and one negative number. Let's say I will send 100 and minus 40. I'll get the result and I would have one assertion again. So what the assertion should be at this time? Assert dot assert equals, I want my addition to return me 60, right? That is what it will return me, 100 minus 40. So res should have 60. If it's not, like if the assertion fails, then I want some message to be printed in my report. So that message should be addition is not working with one positive and one negative. This message would be printed. So let's say these two test cases we have completed so far. We will complete the rest of the ones, but let's see the execution now. Now I want you guys to see the execution. Now, as soon as I run this class, no, how would I run this class, or how would I trigger the unit tests? What I'll do is, in this, I will simply right click on the POM XML, run as, and I would say Maven test. So as soon as I say Maven test, so this is an instruction to Maven to trigger the unit test cases. But will Maven only trigger the unit tests? No. That day we also discussed about this in the last session, that when you ask Maven to perform any life cycle phase on your application, it not only performs the particular life cycle, but it performs all of its prerequisite life cycle. Now what do I mean by this? As soon as I will say Maven test, so what Maven will do? It will execute the entire life cycle for that particular project up to the given life cycle phase. Means I have asked Maven to trigger the test. So what Maven first will do? It will download the required resources. Okay, like it will download the Surefire plugin which it needs to trigger the unit test. It will download the test dependencies. Let's say in this case jar test.ng jar file if it is not there in the local repository. So all those things would be done. Then it will first compile our application source code. Then it will compile our unit test case source code. And then it will trigger our unit test cases through Surefire plugin. So Maven will perform all these things. Okay. So this Surefire plugin will give a call to test.ng, and then that test.ng will run this test class. That is how it is going to be done. So our test.ng is going to run the test cases inside this test class. and testng is going to be given a call by Surefire plugin. That is how the flow is. Now as soon as testng will run this, what I want testng to call very first out of, let's say, you can see here there are various methods here in this class, but which method I want my testng to give a call very first? I want my testng to give a call to this function first, so that I will get my required object of the class created. So how can I tell my testng to give a call to this method very first? By annotating the method as before class. So the before class annotation basically tells testng to call this method as soon as it starts the execution of this test case class. So it will call this method first and we will get our object created. Next, I want my testng to call this test case methods. So I have to just annotate this method with @test annotations. So the methods with @test annotations are the test case methods. So this is the method in which I have one test case implemented. This method also I have one more test case implemented. So I am annotating this also as @test. So all of these remaining methods also would be getting annotated with @test. So for now we are only going to execute these two methods. So this @test, this also @test. Now out of these two, which test case testng will call first, because both of them having the same annotation. So how would testng understand which one to call first and which one to call next? So testng by default calls the methods with alphabetical order of their names. Means if you see the name of this method and the name of this method, so which method names comes first in its alphabetical order would be called first and then the other one next. But if we don't want to rely on the names of with the alphabetical order of their names, we can also provide a priority. So I want, like as a developer, I want my addition to be tested with very basic scenario, that is two positive numbers. This is very basic test case for my addition. So this is my priority one test case. So I want my testng to call this test first. Depending upon the simplicity, obviously you would want a very basic scenario to be tested first. If the basic is not working, obviously the advanced scenarios will not work. So as far as our addition is concerned, this is very basic test case, testing it with two positive numbers. So I want this to be priority 1 and I want, let's say, 1 positive and 1 negative as priority 2. Okay, and once all the test cases are done, what I want the object to be set to null. That calc object, I am done with its job now. So I want to set it to null so that garbage collector will release the memory. Now when I want this to be executed, when I want testng to give a call to this method at the end, once all the test cases, once it is done calling all the test cases, only at the end I want testng to call this. So I will mark this as, or I will annotate this with after class. So what is after class? So after class is a method which testng calls at the end. Okay, once testng starts the execution of a particular test case class, it first looks for a method annotated with before class so that it can call it very first. So it will check the entire class, it will get this method annotated with before class, so it will call this method. As soon as it will call this method, we will get our object created. Then it will move on to call our test cases one by one. So it will first call the test case which is having a priority 1. So priority 1 test case would be called, followed by priority 2 test case. Then it will check, do we have any other method annotated with @test annotation? No, we don't have. As of now, we have only 2 methods annotated with @test. We have completed only 2 test cases for now. So it doesn't have any test case to call now. So it will now stop the execution of a class, but before it stops the execution, it will give a call to a method annotated with after class. And in that after class, we have set that object to null, so that whenever garbage collector of Java would be executed, it will collect the object and it will free up the memory. Okay, this is what the understanding of these annotations. We are going to see few more annotations of test test.ng, but as of now we have understood only these: 1 before class, 2 @test. @test are the test case methods. So test.ng calls the test case methods in the order of their alphabetical order of their names. But if you don't want to rely on the alphabetical order of the names, then you can specify the priority as well. So test.ng calls the test case methods with the ascending order of the priority mentioned. So lesser the priority, higher is the order. That is how it is, right? So it will call the @test methods, and at the end it will call the method annotated with after class. Now let's see the execution. Okay, now let's trigger the execution. And what I'll do is, I'll go here, I'll just simply right click on the POM XML and I'll say maven test. So it will trigger the unit test cases. Now do you see here it says that test runs 2. So there are 2 tests executed. Obviously we have 2 test cases executed there. There is no failure, no errors, no skip test cases. So both the 2 got executed, they are passed. Now we can see the HTML report of this execution also. So where can I find that? Let's go to the project directory structure. Here this is the project. So let's right click and refresh. Okay, and here we should see one output folder. Let me just refresh it one more time. Let me just check here because I don't see that output folder there, but let me see. Okay, let me go to this. Just a second guys, I just want to check. Yes, okay, it's in the target actually. Inside the target you can see the surefire reports, and inside the surefire reports you can see the emailable report here. So if you double click on this, here is the execution report. So you can see, so there are 2 tests which are passed. One is test addition with 1 positive negative number, and another test case addition with positive number. So both the tests are passed, right?